I'm good. I'm sending you my worksheet right now, and I'm going to go get a drink really quick, okay?
Okay.
I just emailed it to you, so you can pull it up and look at it. I'll be right back. Okay, I'm back.
Okay. So, you're studying conic sections. Have you studied anything besides circles? Have you gotten to ellipses or hyperbolas?
I don't believe so.
Okay. Let's talk about circles. To do conic sections, what you really need to do is memorize the general formulas. What is the general formula of a circle?
What, for the radius or the?
The equation of a circle.
Oh, I don't know.
X minus h squared plus y minus k squared equals the radius squared.
Okay.
Okay, where h and k are the coordinates of the center. Now, the first two problems they've asked you about here, h and k are 0. So the center of the circle is at the origin. Okay?
Yeah.
So let's look at A. So we know the center is at the origin. What's the radius?
The radius is, I'm not sure.
This is radius squared. In other words,
okay, so
it's a general formula. On the right side of that equation is the radius squared.
yeah, okay, yeah. I was about to say that too.
So what's the radius?
So it would be 7.
Okay. How about this one over here? B.
That would be...
Center, again, is the origin.
Yeah, and then the radius, so the radius is the square root of 324, which is, I'm not sure on hand, but I could do it in the calculator if you'd like.
Yeah, you should have your calculator handy.
Okay.
Guessing 18, maybe? No, but that's 18.
18? Okay.
No, do it. I'm guessing based strictly on the last digit. If I squared 18, the last digit's going to be 4.
Yeah, it's 18.
Okay. All right. Now let's look at C. Now they get more complicated. They're not at the origin anymore. So where is the center of the circle on C?
It's at +2 minus 3.
No. It's at -2 plus 3.
Oh. Oh, yeah.
That these are all x minus h and y minus k. In fact, everything you have learned up to this point in math is always x minus h, right? You've never had to deal with an x plus h. So just memorize it that until you get the calculus, when you're dealing with an x and an h, it's always x minus h. Even if you're talking about the vertex format of a quadratic, it's x minus h squared plus k. Well, that might be plus k, but notice where that k started. Started over here. So it's still minus everywhere. So it's not until you get to calculus that you ever have to deal with an x plus h. That's helpful. That means that when you're trying to remember what it is, it's always minus. And that applies to all 4 conic sections. it is x minus h and y minus k, whether you're dealing with parabolas, circles, ellipses, or hyperbola. What's the radius on C?
Well, I guess it would be, would it be, I'm not sure.
Square root of 289.
That's it?
Well, look at the general formula. This equation fits the general formula perfectly. They haven't modified it at all.
Okay, x.
They've put in an h and a k is all they've done. But the radius hasn't changed, so the radius is still the square root of 289, which is what?
True. With the 289.
Uh-huh.
Would it be like 17?
You need to do that in calculator. No, 17 is probably right.
Yeah.
Because 7 gives you that 9.
A 9, yeah.
I know it's going to be a whole number. They're not going to give you these things where they're going to give you this big number. Their answer is not going to be 17.12784. You know what I'm saying?
Uh-huh.
Okay. So on D, what's the center?
Plus 14 plus 2.
What's the radius?
The radius is 2?
Uh-huh.
Okay.
Yeah, it's that easy. Everything is dependent on you memorizing that general formula. If you can memorize that general formula, then everything else is going to come natural. Now, if I wanted to plot this last one, I would go to 14, comma 2, and I would draw a circle with a radius 2. And when you're talking circles, there's only two things that matter. And that's where its center is and what its radius is. There is nothing else that even is relevant. There are only two pieces of information that matter for circles, where the center is and what its radius is. Unlike ellipses and hyperbolas and parabolas, there's lots of other stuff going on with those. But circles are the easiest.
Do they ever affect each other, the center and the radius, or no?
No.
Oh, okay. So they're completely independent of each other. Okay, that helps.
Yep.
Okay.
Now, these get a little tougher here. In other words, they're not giving it to you in the form that you want it. Remember what our form is. Our form is Our form is x minus h squared plus y minus k squared equals r squared. Well, they didn't give it to us in that form. And we can take this polynomial that they gave us and put it in this form. And the first step is to gather the x terms together and gather the y terms together. And here's how I'm going to do that. Now, you see where what I've written matches what they gave us. Exactly.
Uh-huh.
Okay? That's the critical step in all of these, is make sure you do not change the function as you go from step to step. Now, to turn what I have on the left into what I have on the right, I've got to complete the square. Complete the square in the left set of parentheses.
How
do I
complete this?
Yeah, how do I complete the square?
You
You take half of the coefficient of the x term and you square it. That's simple.
So
now, when I wrote 16 on the left side of this equation, I changed it. So I got to balance it out by adding 16 to the right side. Now it's the same. In other words, now it's still the same as what I started with. So all I've done is add 16 to the left side and add 16 to the right side. With me?
yeah, so it's you double the
No, I didn't double it. I took
you
half
take
of
it.
8. I took half of 8 and I squared it.
Oh, okay, yeah.
That's how I got 16. And I'm going to do the same thing in the y term. I'm going to take half of the coefficient of y and I'm going to square it. So what do I need to write here? And it's always added. Because even if it's a negative number, when you square it, it turns positive.
Yeah, so it would be, what, is that negative 2? So, so it would be negative 1 squared, which is just 1.
Correct. Now, I just added 1 to the left side. I got to add 1 to the right. With me? Now, the whole reason I completed the square was so that I can write this term as a linear term squared. And I can do that. It's x plus 4 squared. And the only reason I can do that is because I completed the square. And what's the next term going to be?
Next term is going to be y. Okay, y squared.
No, it's y minus.
It's y minus.
Write it as a
Oh yeah, we're completing the square, so it's just y net minus 1. And then that's the
square.
And that's the
And now the right side, I add up all my numbers, I get 81. So that's what the right side is 81.
Okay.
Now, this is identical to what I started with. It's just I manipulated it algebraically so that I could put it into this form. And that's a very common practice with all conic sections. You want to get good at completing the square because you have to complete the square virtually with every single problem where they give you a polynomial like this. In other words, if they don't give it to you in this format, you got to put it in that format. Okay? Now, tell me about this circle. Where's its center and what's its radius?
It is minus 4 plus 1, and then the radius is 9.
That's all you need to know.
Okay, so let me try it for B then.
Okay, hold on a second. Yeah, I'll let you try to handle B on your own. I won't erase that standard, but at some point you want to memorize that. Can I erase it? I'd actually prefer to erase it. Not because I need the space, but
okay, go ahead.
The best way to memorize stuff is to not have it in front of you.
Okay, go ahead.
Period.
Okay, so x squared, would the y go with the x or would the z go with the x? I mean, like, because y becomes before z, but,
This is actually the equation of a sphere. This is a typo. First of all, you do not have 3 variables when you have circles. Where you have 3 variables is if you have a sphere. In other words, if you have a sphere in 3 dimensions, a ball, it's going to have a x-coordinate, a y-coordinate, and a z-coordinate. I think this...
Oh, that's why there's a z.
Right, I think this was a typo. No, I don't think that's meant to be z. I think that's meant to be x.
Okay, yeah, maybe it was a typo. Okay. So
almost positive of it.
What does the rest of it work when it's
Let's
x?
make it an x, and then let's solve it. So tell
Okay,
me,
x squared minus 22x, and then
leave room to complete the square.
yeah, and then y squared
It-
minus
gotta be-
24y
It's got to be plus y squared, and
plus,
that's important because that could be a minus, although not with circles. If that's a minus, then you're looking at hyperbola. But, okay, and then the minus 24y. Leave room to complete the square, and move the 261 to the other side.
Why does it equal 0?
Well, all they did was give you a polynomial. That's what that is a standard two-variable polynomial. And so we had to start putting it into the form for the equation of a circle, and the first step is to move that constant to the other side.
Uh-huh.
But make sure you understand why that is identical with what we started with.
Okay, so anyway, now we gotta complete the squares
Okay, so
by...
tell me how to complete the square.
So you take 11 squared, which is
121.
121, and then you take...
Hold on. I can't just arbitrarily add up.
Yeah, you gotta add the 121 to negative 261,
Okay.
and then you gotta take negative 12 squared, which is 144. Add that to 24y, and then add that to 121. And then you gotta take now it's x minus, x minus
Whatever you got when you took half of that.
11, x minus 11 plus 1
Squared.
No,
Got to be
squared.
In other words, the
And
whole
then-
reason we completed the square was so that we could write this as a linear term squared.
Uh-huh. And then you take y squared minus
No?
12,
Y
and
minus
y squared plus.
quantity squared. It's not y
Huh?
squared minus 12.
Sorry.
Y minus 12 quantity. Okay?
Yeah.
What's that all equal to? That's 265 minus 261. Looks like...
Isn't it just 260? Yeah, wait. Yeah. Okay.
So where's my center?
It is plus 11, plus 11, plus 12.
And what's my
Or
radius?
2.
That's how you do it. Now,
Okay.
we don't have a lot of time. I want to make sure I cover a principle that is important.
Okay.
I want to give you a completing the square problem where there is a coefficient like that.
Is this your own make?
Yeah, just making it up. It's going to illustrate what I'm trying to show.
Mm-hmm.
How do you complete the square here? First of all, let me say, you cannot complete the square until the coefficient of the x squared term is 1. You can't even begin.
So you gotta...
Factor out that 2.
Okay. So... Yeah.
Now it's still the same thing. I haven't changed anything. But now I can complete the square because the coefficient of x squared is 1.
Yeah.
So
now you have to... What? Like...
keep it in ratios. Don't use decimals. In other words, if I divide 3 by 2, it's 3 halves. Now square 3 halves.
So... Wait, what'd you say? Sorry, I didn't...
Say keep it in ratios. If I divide 3 by 2, I got this, and then square that. So you
Oh, okay.
9/4, rather than switching everything to decimal.
Yeah, okay. So you would take the 3 and put in a half, and then it's plus 9/4.
Now, how do
And
I
then
balance that on the other side?
it's just 2. Is the 2 stayed out of the parentheses, or do you put it back in?
Well, when I wrote 9/4 in there like that,
It's assuming that the
I
2
didn't
is out
add
of it.
9/4 to the left side of the equation. I added 2 times 9/4. So I have to add 2 times 9/4 over here.
Oh, okay, yeah.
That's why I wanted to show you this problem, is that if you start with a coefficient in front of the squared term, you have to factor it out. Even if it doesn't factor evenly, you got to factor it out. And then when you complete the square, this term has to be multiplied by what you, in other words, when I write 9/4 in there, I'm adding 18/4 to the left side of the equation. And remember what my goal is. My goal is to go from step to step without changing anything.
Mm-hmm.
Now, what's the next way? What's the next thing I can do?
Well, now you got to go and complete the square. So you just do 2,
We already
2, and then in the parentheses x plus 1, or x plus 3 over 2, and then that's squared, and then
and notice
you have,
this sign is always the same as that sign. The middle term. If the middle term is negative, then this is an x minus. Okay.
Mhm.
Over on the right side, I got to add 18/4 to 5. That's 38/4.
Mhm.
And so that's what I ended up getting. The only reason I made this problem up was to show you that sometimes completing the square can be extra difficult. Now, I don't see any problems on here where the coefficient of the squared term is anything other than 1. So it may be you don't have to deal with that. Let me have a look here. Yeah, that's 1, that's 1, that's 1, that's 1. Okay, so far, nothing in this document requires you to do that, what I did on that last problem. Because all of the squared terms have coefficients of 1. Not a single, not A through D have anything but coefficients of 1 on the squared term.
Mhm.
All right, so, yeah,
Let's just do one.
that can't be a Z.
Yeah, it must have been a mistake.
Unless
X
they're
is
talking
X,
sphere, and that,
X is right.
that would not even be the equation of a sphere. The
Yeah, because there's no other
equation would
Z.
have to be Z squared.
Yeah, but I think X is right next to Z. He probably just made a mistake when he was typing it out.
In other words, the equation of a sphere is x squared plus y squared plus z
Plus Z squared, and then
r squared. It's virtually the same equation with just one extra dimension or one extra variable.
All
right.
Okay, you want to do one more then, and then we'll wrap it up.
Let's see. We've got 5 minutes. These are at the top here. These are both completing the square problems. Circles. Let's do
What about E?
one of these. Let's do E and F. Give me the equation of this circle.
X squared, or no, X minus H.
Okay, this is H.
Yeah. Oh, so X plus 11, and then n parentheses squared.
Squared, yeah.
Plus X or Y parentheses Y plus 8 squared equals 16.
You got it.
Okay, that's pretty easy.
Yeah. No, it's pretty easy to go to do these. Well, let's do this one. This gets a little more difficult. Add an extra wrinkle here. So,
with the 18 pi?
But that's going to be easy because we're going to be able to figure out what the radius is, right? If we know the circumference, you know the radius.
It's just half.
Well, it's not half. We'll have to figure it out. But let's first of all get...
Oh, wait, no. Yeah, I'm talking about the diameter.
Well, right. Let's get the rest of it first. So,
Yeah. Okay, so x plus 6 squared plus 5, or plus y minus 5 squared equals...
okay, now let's go over here on the left. The circumference is 2 pi r.
2 pi r, yeah.
And
so
that it's 18 pi. So if that's 2 pi r, what is r?
R is 9.
So what goes over here on the right side of my equal sign?
81.
There you go.
Sweet. Got 3 more minutes? You want to try it?
Yeah,
or do you have
no, I can do this one, I think. You find a circular plate fragment that has a width. A circular plate fragment. Well, a circular plate fragment. Let's make up something that might be what they're talking about. Let's assume that we've got this much of a plate. Okay? Except none of this makes sense. Where is the width measured and where is the height measured?
I don't know.
I don't either. A circular plate fragment. Doesn't say semicircular. I still wouldn't know what the height and the width is unless they're talking about something that looks like this. Let's assume they mean this.
Okay.
Because I don't know what else to do.
Yeah, I think that works.
Yeah, this probably is what they mean. And it has a width of 24 centimeters, and it has a
height of 8.
That's not even going to work. Notice
because we don't know.
Yeah, but
we don't know how big the...
Well, it can't be a semicircle, put it like that.
Because we don't know how big the original plate is unless we know how big the fragment is of the plate.
That's why this problem doesn't make any sense at all.
Okay. Well,
even if
I guess we're
semicircular, this couldn't be right because that would be the radius, and therefore 24 couldn't be right. So something is funky about this problem. Yeah, they need to draw a picture or something to show us what this circular plate fragment. If I just draw a whole circular, that's not a plate fragment, that's a plate. So it's hard to tell what they're talking about.
Okay, well, I guess we covered enough for today.
Okay. All right, Dominic, I will talk to you on Thursday.
Yep, Thursday it is. I'll see you then. Goodbye.